Hello, I am Philippe, and I'll be going over improper integration. So we're going to start with the example from the integral from 0 to 1 of 1 over x. And you wouldn't do this normally, and we'll just do a quick picture of this. So it's going to be, the graph is going to be, something like this, and we're taking the integral from 0 to 1. So the area, this thing is going to go all the way up to infinity, and so this area is, we can't really just say that. We can't really use any traditional methods for it. So to counter this, we just take the limit as x approaches of function, and then we evaluate. So we ln of 1 ln x. In this case, it will diverge. So again, we just, if we want to check, we use improper integration when the limits, when the endpoints of limits or the things in between the limit do not exist in the function. So in this case, 0 didn't exist, or if you have like infinity, that's also improper. And so this is where we would use this limit method in improper integration. Alright, we're going to do another problem. Alright, we're going to start off with this example. The integral from 0 to infinity of this function right here. I already took the antiderivative. Here's a simplification. This is just some integration by parts, and this is the antiderivative right here. So we're going to focus on here. And you know, for the improper integral, you're just going to take the limit in which it's infinity or where the function does not exist. So we're going to start here. To write this out, and this will be 0 when you plug in 0, and you'll get a plus 3. The fundamental theorem of calculus. So we take the limit as x approaches infinity. Negative 3 e to the negative infinity. Let me make a little note here. As e to the negative x approaches infinity, this just equals 0. So this will equal 0. We can kind of cancel that out. Here you want to be a little careful. So if the limit is x approaches infinity of this, so we have negative 2 times infinity times 0, this is not just off the bat 0. Infinity times 0 is indeterminate, so we need another way to write that. Do some quick manipulation. And then we get infinity over infinity. We use some L'Hopital's rule, which is take the derivative of the top and the derivative of the bottom. And redo the limit, and we this equals 0. So this whole thing, these just all go to 0, and we're left over with 3, so this thing converges at 3. We're going to do another problem. Alright, now we're going to have a limit of negative infinity to infinity with this function. This is the steps for the antiderivative, and this is the antiderivative right here. Alright. So we have to be careful. We can't just substitute limit as x approaches infinity, but an x and a negative x. We have to split this up into two integrals, and we'll pick 0, the half point, between these two integrals. And that's how we would set up this integral. We just split it in half. And make sure infinity is on one part and the negative infinity is on the other. Alright, so again, this was our antiderivative, so we'll just evaluate these. Alright, so we'll first start as this limit goes to infinity. As this limit goes to infinity, this thing goes to 0 because you're going to have infinity in the denominator and the number on the top. So this just goes to 0. This will stay at 3/2. As this thing goes to negative infinity, the negative will be cancelled by this fourth power, and again this will go to 3 over infinity, which is 0. And so we have 3.5 minus 3/2. So that just goes 0. So this converges at 0. The area is 0. So when you have two limits like this, you're just going to split it up into two. Make sure that each part that doesn't exist is on a different integral. take the limit of both and either add if they both converge or if they diverge and it diverges. All right, for our next problem, we're going to do from 0 to infinity of e to the 1 over x squared. This is the antiderivative, and this is the antiderivative right here. Alright, so you might think, okay, well, why don't we just do the limit as x squared is negative infinity off the bat? And that is true, but we have to be careful because the function does not exist at 0 either, as there's an x squared in the denominator, so you put a 0 here, it won't exist. And therefore we need to do two integrals, kind of like how we did from infinity to negative infinity. And so for here, we're going to make -1 this time, our little point in which we're going to do both these at. So it would be from x to -1, 0, that, and then from -1 to x, as the limit goes to negative infinity. So again, like we did before, we just split it up, and we have a point in which they're both common. And then we already know that antiderivative is this, so we're just going to solve. Alright, so with that, as this goes to 0, negative e to the 1 over x, when this is 0, this would be a negative number. So 1 over 0, the left-hand limit, is just going to be negative infinity. So negative e to the negative infinity is 0. This will stay the same. This will also stay the same, so you can kind of cancel these out. And then e to the 1 over negative infinity is just 1. So this converges at 1. Alright, so we're going to go to the next problem. The integral is 0 to 4 from x over x squared minus 9. Now, this thing looks okay, doesn't it? The 4 passes, the 0 passes. However, we have to be careful because in between these, 3 doesn't exist. There's no defined function, 3 over 9 minus 9, 0. So there's a 3 over 0. And as we did in the last two integrals, we have to split up into two integrals again. From 0 to x, 3 left hand. And then from 3 to x to 4 with 3 upper limit. So you have to be careful. You want to check to make sure the limits are continuous throughout and not just at the endpoints. And the antiderivative is right here. So x squared minus 9. All right, so as this goes to 3, this becomes this would be 9 minus 9 is 0, or this is like saying 2.99999. So 2.999 squared minus 9 is this will always be greater than what this is going to put it in. However, it's be 0.000001. It's going to be the ln of 0.0000 repeating 1, which is just negative infinity. So negative infinity over 2, that's 9 over 2. This thing will diverge because it's just going to negative infinity. And if one part of this diverges, the whole thing will diverge. So we can just write this diverges. Alright, finally, integral from 1 to infinity of 1 over x over p. 1 is this divergent or convergent. So we're looking for what p values will this be divergent or convergent. This is a good thing to note. If p is greater than 1, this thing will converge. If p is less than or equal to 1, this thing will diverge. So that's a good thing to note when you are dealing with these functions. You just can use this to determine whether it will converge or diverge. Alright, thank you for watching, and there will be a worksheet key available in the description of this video.